Hi, and welcome to another episode of Behind Our Science. I'm one of your co-hosts, Daisy Shu, alongside my co-hosts, Roberto and Vic Meadows. It's been a busy year for all of us, with many transitions occurring in our lives. One big milestone for me was getting married in February this year, where I went back home to Sydney, Australia for my wedding. And after the wedding, we went on a conference honeymoon to attend the International Society for Eye Research conference up north in the sunshiny Gold Coast, which was a lot of fun because it was the 50th anniversary for ISA. So we all celebrated with a massive cake and a gala dinner, which was a lot of fun. And we shared a lot of our latest eye research findings. So it was fantastic to see so many researchers from all around the world travel down to the Southern Hemisphere to participate in the ISA conference. And my colleague and friend, Dr. Menglu Yang, who's currently a faculty instructor in the Department of Ophthalmology at Harvard Medical School, was my lovely bridesmaid and also attended the conference for ISA. And in this episode, Menglu participates in our 7.3 questions segment and shares some fun facts about her life in the lab. Roberto also has some very exciting news to share. He's actually secured a new position as assistant professor at the University of New Mexico. A big congratulations to Roberto. In this episode, Roberto shares some footage of his transition journey and talks about this journey of transitioning from Pittsburgh to New Mexico. In this episode, we also feature an interview with Dr. Heather Francis by Vic Meadows. Dr. Heather Francis joined the Division of Gastroenterology and Hepatology in January 2019 as a scientific director of the Indiana Center for Liver Research and a professor of medicine. Dr. Francis recently was an associate professor of medical physiology at Texas A&M College of Medicine, where she obtained her PhD in 2010. She has established a very strong research group focused on understanding the impact of mast cell and histamine signaling in various liver diseases, including fatty liver disease, cholestasis, and cancer. Dr. Francis is an impactful mentor and a champion for women in science. In 2018, Dr. Francis received the Distinguished Alumni Award from her alma mater, Sul Ross University, and was recognized as the new Investigator of the Year for the American Physiological Society GI and Liver Specialty in 2016. The Francis Lab is currently funded by both the NIH and a VA merit, and her past funding includes a VA Career Development Award and funding from PSC Partners Seeking a Cure. We really hope you enjoy this episode. We also have some very exciting episodes lined up for the future on topics such as plant biology and science sustainability, so stay tuned.
Now we have 7.3 questions with Dr. Daisy Shu and Dr. Menglu Yang.
Hey, come on here.
Hi Menglu, thanks for being on 7.3 questions with Behind Our Science.
I'm excited.
So what's keeping you busy these days?
Experiments.
What's the best vacation you've ever had?
It was the Sydney one for a wedding.
Yay!
Yeah, all our vacations are here.
Cool, lots of fun spots you've visited. What are you currently reading?
I'm reading a book about a Cambridge student who can't find a job in academia, so she ended up working in a bookstore.
Ooh, interesting. What experiments do you currently have going on?
So I'm working on an immunofluorescent assay on trigeminal ganglion cells. We'll have the result by today. I'm really excited about that.
Ooh, exciting. Fingers crossed it goes well.
Yeah.
What's your favorite assay?
So my favorite assay is this one. So we have this special microscope to detect FIRA2 signal. That's a calcium indicator. And using this system, we are able to get a correct calcium levels inside the cells.
Oh,
with proper calibration, of course.
Very nice. And what's your favorite pipette?
My favorite is this one, because it's really easy to handle. Doesn't break my thumb.
Ergonomic. Minus 80 or minus 20?
Minus 20.
What's next on the horizon for you?
Getting grants.
Yes! Get the grants.
Grant up.
Thanks for joining us today for 7.3 questions with Behind Our Science.
Up next is On the Move with Dr. Roberto Moda. He will show us what it takes to move himself, his family, and a lab from Pennsylvania all the way to New Mexico.
So over the last few months, we've been planning a bit relocation for myself, my family, and my lab. So we decided to leave the University of Pittsburgh a couple of months ago, and we decided to move to a place that we called home a while ago. So we moved to New Mexico, especially the University of New Mexico, located in Albuquerque, New Mexico. We made this decision, a very hard decision, because we wanted to be closer to family. We wanted to feel at home for a while. I took a big risk in 2014 to come from Mexico, coming to the US, to the University of New Mexico. And after a while, we did a lot of moves, a lot of changes, transitions, and we had decided that it was time. It was time to come home. It was time that not only the science was guiding my career and my life. So then, together with my family, we made the decision to move back to New Mexico, which is almost 3 hours away from Juarez, where I was born. We have most of our family, and feeling closer has been something that we've been looking forward for quite a while. So this was a transition that had long overdue, but that we've been very excited to have, especially because of my career. I mean, having been at the University of Pittsburgh for almost 3 years, it has been an amazing ride where I was a research assistant professor, but now moving up the ranks to an actual assistant professor where I have my own lab, my own group, my own funding, which we've been very fortunate to be successful in obtaining. This has been a big transition, and again, not just because we are moving across the country, but also because we're moving in that process, that academic rank that all of us are looking for. And has been challenging, but it's more exciting than challenging. I've been feeling so welcomed and so reunited with what we felt was home for quite a while. I felt the interactions with my family, what they wanted, what they were urging for, and what they really wanted me to focus, which was also, again, in making them happy and finding true happiness through your career, but also in your life, and having all of these experiences that actually enrich such a enduring career, which is academic research. And as such, I believe we've been coming back to something that was really true to us, that we were urging to come back to. My oldest was here, for example, in this picture. I mean, he was here very young when we came to New Mexico, and now with 9 years old, I mean, now seeing my youngest in that transition, and the importance of the family connections that we have here are huge. I cannot say that we didn't miss all the food. I mean, having this vast array of different things that we can actually have close to home. The ability to do this has been amazing. And so just showing through the different concepts of again, relationships with yourself, with your career, within the people that you're working with. This is sort of like the path that we've decided to go for. We're very excited and very, very thankful for the opportunity to work here. This is one of the main buildings where we are located, and it has been great because we've been very fortunate in securing, with the things of the Pharmaceutical Sciences Department here at the University of New Mexico and the Health Sciences Center, through a fantastic group that helps me and boosts my confidence and my happiness in coming in to work every day. We have an ample space that we call our research group, that we are able to become efficient, successful, and also very determined to continue our path here in New Mexico because we feel it's the right move. And we wanted to share that with you guys, with our listeners, the people that are actually excited about all of these things that happen behind our science and that are guiding the experience that most people that are going through this career stage, either coming from postdoc to faculty or any other position, but are also engaging in cultural differences and cultural shock when you come to the U.S. or coming from a different, maybe a family or leaving family members behind. It also endures, again, the importance of being connected to the stuff that happens behind our science, which is the stuff that motivates us to be successful. And in that sense, we've been diligent in obtaining and securing this research space here in the Research Incubator building, and the MRF, which is the other space that we also haven't been able to obtain. It's been amazing to come back to something where we find the collaborators feel like it feels like family. It feels like people that I actually never left. People that are very happy to see me, that I interact and I never stopped interacting with. And so in this transition that we've done, again, to the University of New Mexico, we found that all the different things that guided us and took us to the different places that we were fortunate to be at the University of North Carolina, the University of Texas Southwestern, the University of Pittsburgh, and now coming back to the circle to the University of New Mexico has been fantastic. I think I cannot extend how much of fortunate blessings and happy I feel that we are able to do this. I mean, through walking you guys through what our normal and daily life work and life balances looks like here at the university, as well as, again, what we call home now in Albuquerque. It's very exciting, and it's something that I feel it's important for this times. People are also looking for that. They're looking for what makes them happy, makes them feel fulfilled, as well as not leaving behind the other aspects of life, which, again, we're fortunate to be able to have and be able to secure. But the reality is that it's tough. It's tough to become resilient that much that you put or you place some of those efforts and some of those things that you're looking for in the back burner. And academic research is it's a long race. Takes stamina. You have to be able to do this with the confidence that you are feeling happy. And again, with the sense our research group has grown into that, we are very, very thankful to be funded through the Clinical and Translational Science Center, which is a big step in our career and something that would boost the confidence that we have in moving our research forward, which is the help that we obtain in actually doing and securing funding for clinical projects that move the needle or push the needle forward. And research will actually be incredibly relevant and important in the next few years that we're here trying to move into the tenure stream, which is something that we and Behind Our Science are wanting to tackle more, because that's one of our main objectives. As researchers, what's important for us is also feeling secure and feeling that we can do research while taking risks and bringing up new ideas, but feeling that we are having a place where we find secureness, where we find confidence in the support from a department, which we have, again, we are incredibly thankful to have. The Dean of the College of Pharmacy, the people here at the Health Sciences Center, our department chair, who we are also transitioning into, and we are going to be having him in our podcast in a couple of episodes. But very thankful because, again, the idea of being able to move forward with what I envisioned in the beginning of my career would be long and tedious and very, very difficult has been blessed by multiple people, multiple mentors, and people that have helped me see things in the right way, which is you have to put your head down, work, do the hard work, but also be able to see things as they're not done. You're almost never done. You're always looking into more opportunities and where we can actually benefit health, where we can benefit the taxpayers, who are people that are supporting our research, the stuff that we want to do to be able to make life better for everyone. And in that sense, we've been, again, very, very blessed to be able to have this either through collaborators, mentors, and now hopefully that we have our own research group now in ourselves. For the people that are looking at the video, I mean, I'm showing you guys here what is the current hospital here at the University of New Mexico and the new hospital that is coming up. So many of the things that we're trying to implement in our clinical research program, as well as the translational component, is very much supported by all of these different things that are happening here at the University of New Mexico. People that are wanting to come here, become a family, because we are that. We are a small university, but with great capabilities. And as I'm showing you here, guys, here again, the people that I can see it in the video is the Clinical and Translational Science Center, which is one of the greatest tools that I've found to be able to foster and advocate for my success, which is, again, doing translational and clinical research. And in that, we've been blessed to become a KL2 scholar that would actually boost our opportunities in securing funding, as I mentioned, for our clinical opportunities and research program that we're trying to move ever so slightly forward. We're always trying to think positive and forward to securing all of this. And in this sense, as I mentioned, the opportunities here have been fantastic. I am also very thankful to be able to share this with you, with everyone that's listening. I hope that everyone gets a little peek of what we are into. I mean, it's only almost been 2 months that I've been in this position, but we are very happy and, again, very excited to what's coming. The greatness of these academic opportunities is that, yes, there are a few, but the ones that we have been incredibly blessed to obtain is that we also want to be able to give other opportunities for people that are coming with the same background but with the same drive as we have, which is to make something out of our time here, to be able to be productive, push forward trainees that are, again, in that same mindset to give more of ourselves into our careers, so that our careers create a legacy that comes to research. Not just the name of our lab is securing biomedical advances that help us make life better, more sustainable, happier, endure more time with the people that we love, the places that we value, and the things that we acknowledge as important in our lives. So in that sense, I wanted to give everyone a tour of what we've been up to for the past couple of months. We think we're almost settled here at the University of New Mexico, and we are very excited to have all of this opportunities, and we look forward to every single one of them, with the new research space that we have, the new buildings that we've been able to be a part of, and we are a part of, and with the great opportunities and places that we've been fortunate to live in. I mean, we can only say that Albuquerque has a great place in our hearts. So thank you, everyone, for listening.
Our scientist interview today is with Dr. Heather Francis, Professor of Medicine from the Indiana University School of Medicine and Scientific Director of the Indiana Center for Liver Research.
We're very excited at Behind Our Science today to be meeting with Dr. Heather Francis, who is a professor of medicine and the scientific director of the Indiana Center for Liver Research at Indiana University and Robert L. Rodebush VA Medical Center. She received her Bachelor's of Science in Biology from Sul Ross State University in 1990 and completed her PhD in 2010 at Texas A&M University's Health Science College. We're very excited to have her today, not just because she's an amazing woman in pathology, but also because she was my mentor for my PhD. So it's always exciting to have Dr. Francis around and have her share some of her knowledge. So if you want, go ahead, Roberto, and ask the first question.
Yeah, thank you, Dr. Francis. So we'll start with the first one because we're very interested in what you do research-wise. So Can you tell us a little bit about your career trajectory and what is it like for you specifically to lead a lab?
Sure. So first, let me just say thanks to both of you for inviting me to participate in this. And I'm always excited to share what we're doing in the lab, but also, some insights and how the dynamics and how things can kind of come about in your life. So I had a Bachelor of Science in Biology, and the way Vic presented that sounded like it took me 30 years or so to get my PhD, but I had a large break in there where I had different jobs and was working in a clinical setting when I decided to go into research and became a bench technician. And I did that for almost 10 years before I sort of just made a decision to pivot and go back to graduate school. And it was during a time when Texas A&M was allowing that to happen remotely, way back before Zoom or anything. And so I was able to do that, take care of kids and still work in the lab, and completed my doctoral work. And then from there, decided to kind of jump in and start a science lab, a basic science lab, under mentorship, but still trying to develop my own personality and my own, science and what my niche was going to be within that field that's very broad of hepatology and very specifically more biliary pathophysiology, cholestatic liver disease, fatty liver disease, and liver cancer. And so I've sort of carved myself out a niche there, looking at the mast cells within those liver diseases.
That's great. Most of the people that we were trying to interview or showcase in our podcast, we're trying to also understand whatever happens like behind the science, right? So, do you mind asking us what factors pushed you or guided you to investigate this specific cell lines in this pathology, biliary pathology?
Sure, absolutely. So the lab that I was working in is a cholangiocyte physiology, pathophysiology lab. And so I trained in a very heavy cell-to-cell interaction, mechanistic, basic research lab. And when I started doing my doctoral work, I was working on histamine globally as a molecule, looking at cholangiocytes within the liver. And then I had a mentor on my graduate committee, and she had done some work in mast cells and just sort of one day said, you might think about this because, that's where most of the histamine is coming from, which we knew, but we hadn't investigated at all. And so with her encouragement, I put that spin into my doctoral work and in my dissertation, not really knowing what would happen if people would believe us. I had a lot of naysayers. And so it was a sort of a leap of faith for me to bring those cells into a discussion that's primarily about resident liver cells. So cholangiocytes, hepatocytes, Hoover cells, hepatic stellate cells. And then I'm bringing in this random immune cell from nowhere and saying, hey guys, it really does play a role in the pathology of diseases. And so that was sort of how I came about that. I mean, it really didn't happen just by myself. I had a lot of encouragement from Dr. Meininger about that. So she really was the one that pushed me to look at the mast cells, and turned out that it's been a good suggestion all these years.
Yeah. And so related to that, when you're thinking about like proposing an idea and then coming to life, meaning like from the moment that you start this idea to the actual publication or completion of the project, what is like a typical, not a timeline, but the time that it takes you to start a project and then seeing it to completion?
I mean, it can depend on the project, but in general, you can start generating data and it might take you 4 or 5 years before you're ready to submit that actual product. And in that time, you probably presented abstracts, talks, posters, research in progress that kind of get you to where you're going. A lot of that also depends on, the dynamic of the lab itself. So for instance, with Vic, we started her work, and then we had to move labs. And not only just did we move our lab, we moved across the country. And so that put a huge disruption in all the work that we were doing. COVID also did the same thing, and that just extended these projects. But typically, I mean, it seems, it sounds dramatic when I say it, but I do think that it can take, you know, a solid 4 years probably, unless you just have, you know, maybe 1 or 2 projects. But when you're working on 5 or 6 at the same time, then it can really drag out a little bit, which is a little dangerous, because when you think about publish or perish and you relate that to grant funding, there's a lot of pressure out there to get those papers out a lot faster, because, you know, people want to see productivity.
Yeah, that's true.
On that note of publish or perish, does writing manuscripts energize you or exhaust you?
I mean, it does depend. I have found over the years that there have been papers that I've just had a real affinity for, and a project that I just really am passionate about, and then the writing just flows. If it's a project that I'm struggling with, that maybe the data is just like all over the place, we don't understand it, it's a new topic, it can be a little bit more exhausting. I will say that I do enjoy writing discussions. That probably to me is like my most favorite part of a paper, just because, you know, you have the methods and all of that's very technical, and it can be very kind of daunting, where the discussion, I think, is a place where you get to not just say what you think the results mean, but, you know, find things that support it or refute it. And so I think it really depends on the project, but overall, I personally enjoy writing. A lot of people don't, but I really do.
No, that's good. I feel like as a PI, or at least from my perspective, PIs have to write a lot. So if you enjoy it, that's a good
thing. If you don't, you're really kind of, that's screwed. That's bad, because it's hard to rely on everyone else. You know, because you get trainees, sometimes they do really well and they write, you don't really need to do a lot. And then you get some that you have to rewrite everything. So yeah, you have to like it if that's the field that you're thinking about.
Yeah. So we've discussed a lot about how long it takes to get a project up and running, and publications and writing, but what do you like to do in your downtime to unwind?
Oh, so like hobbies? So I love movies. I see a movie probably weekly, if not more. It's something I just really enjoy, that even just go, even if it's a bad movie, just going to the theater, there just has always brought me a lot of like joy. I like to spend time. I have 2 dogs. So I have a mini dachshund who's, you know, getting older. She's not doing a lot, but I recently adopted a golden retriever. And so I've been spending a lot of time with her, just trying to get her used to the real world and what it can actually offer. I love to travel. I, you know, really enjoy seeing new places and meeting new people. And cooking, that's also probably one of my biggest things, is I do love to cook. So the pandemic was like good and bad for me, because I could stay home and cook, but I couldn't go anywhere.
Events for the people, like what's been a recent movie that you watched that you would recommend?
Oh, recently? Oh, that's, I'm gonna have to think about that one. You'll have to give me a minute. I've seen so many, and so many were bad. A Man Called Otto was excellent. Not so recent, but it was like Christmas time. It was fantastic.
Okay. And so you said a couple that were, I mean, I love watching movies that I hate, like like Sharknado and things like that. Me and my kids love it because it's like it sucks so bad and good. Is there one that probably you would highlight?
Yeah, and I hate to say this because I love Liam Neeson. He's one of my favorite actors, but I think the movie was Marlowe, where it's like set in, you know, like the 1930s. That was really cool, but the story was so boring. It was just so flat. I'm like rolling my eyes, and that was a disappointment, because I really thought that would be a good one. He's so good, and the scenes and the set design were incredible, but really boring. Definitely a stay-at-home type movie, and probably I wouldn't even watch it then.
Nice. Yeah. And the last one, favorite movie, worst movie?
My favorite movie. Oh, this is crazy. One of my favorite movies is Jaws, the original. And worst movie, Step Brothers. I got up and walked out of the theater.
Oh my God.
Yeah.
That's actually
Not
that
even-
was one of,
not
that's
even
one of my
20.
favorite.
I know,
that's
not
my
even 20 minutes in. I kind of regret it. Like I see it on streaming and I'm like, maybe I need to give this another shot.
No, it's
I love both of them.
it's very bad. It's very
But-
bad.
Yeah, it's,
I left. That's the only time I've gotten up out of a theater and walked out.
All right.
wow, incredible.
I know.
I quote that movie all the time.
I can't remember. I can't believe that I could remember that I got up and walked out of that movie. Seems so dramatic.
Oh no, that's pretty good. If there's a movie to walk out of, it is Step Brothers. It's like very like extreme.
I saw some people walk out of. I don't know if you ever saw Natural Born Killers. It's really a tough movie. Woody Harrelson and Juliette Lewis, maybe I can't remember, and very bloody. And some people were sitting in front of us, and they got up and walked out. And in that moment, I was like, "What morons!" So probably somebody said that about me when I got up and walked out of Step Brothers. So.
Yeah. No. There's multiple ones that we know. Yeah, we might need to create a like a panel of people that discuss movies, because I think there's some secret gems that people will probably miss due to like.
Yeah, I would love to be part of this.
Yeah. That would be fantastic.
I have a lot of opinions about movies.
Yeah, we're gonna have to do something like that. Thank you.
Okay, so back to a little bit of science. Which histology stain is your favorite?
Okay, so I thought about this question a lot, and up until probably 2011, maybe I didn't even know what a histology stain looked like, because we just didn't do them, right? But when we started looking for mast cells in the liver, we started using toluidine blue, which is the most boring stain ever. But at the moment, it was very exciting when I remember when we found them, and like we had different samples from different models that were treated. So, like carbon tetrachloride, bile duct ligation, et cetera. And we were so excited when we saw those. We don't use it anymore now. And now probably I would have to say I love a good immunofluorescent stain, triple, double stain, like a really nice bile duct, a portal area, especially in the human samples where you can really appreciate, whatever that phenotype is you're looking for, a marker that you're looking for. So I'm very envious of the stains that I see people share on Twitter and things like that. So I just think the intestine probably stains way prettier than the liver. I understand that, but
yeah,
yeah, they are beautiful.
We have the Angevik sisters here who do staining that I don't know how they managed to do something like that. They look so beautiful that it seems like it shouldn't be science. It should be art.
I agree.
Not replicate. Yeah, we're gonna have them on the podcast soon. I'm actually thinking about flying a couple of them to my lab and help them set up like whatever you guys do on your lab, like just make it pretty for me, because they're really good. So
they are. I agree.
So now this one's a little bit more pointed and I guess selfish, but do you have any advice for aspiring women in pathology?
Well, I mean, my advice always for women in pathology and science in general is make sure that you find yourself strong allies. Find and surround yourself with strong women that can be your mentors, but also your colleagues. And, not to say that men don't have anything to bring to your career, but if you want to have those conversations, I think that only women can understand, then you need to surround yourself with strong women, allies, friends, colleagues, mentors, in different areas too. So like broaden your horizon. Don't think that, attend a different meeting, meet different people. This is, I think, the best way that you can be successful, because without support, it's really difficult. It can be very isolating to be the only woman on a panel. It can be very isolating to see no women on a panel, and then they're talking about things that affect women. These things are, I think, topics that even the most generous, taught men, they just still can't relate to. So you need that, I think, as a woman in science. And don't be afraid to speak up. Don't be afraid to ask for what your worth is. don't apologize for that. And it's really hard. It's hard. I mean, as someone that had to make a move and do negotiating, there's nothing worse than having to do that, but then also to be compared to other people, if that makes sense. So always try to remember what your worth is and what you bring to the table, because you do bring something that's completely different from the other people that are around you.
Yeah, and I think it translates to, again, female minorities, whoever it is, right? I think the reality is that we need to find allies, and it is difficult to find. Some people are more strong-minded. Some people are more willing to talk. And that's true. I have a lot of female mentors, male mentors, different ones, right? I think it's good and valuable to find fortes in every mentor. So I have mentors for everything. When I want to hear something straight up, I go to someone specifically, and I know who's going to tell me, stop complaining, just do. And then, but it's good to hear from different people, right? So I think it translates to many different ways. And it is true. I mean, some male mentors might be more difficult to approach in some different aspects, and it's totally normal. And some female mentors might not as be, but I think it's a good mix. So I think it translates to those different aspects. So yeah, it's totally great.
I hate to say that, because I don't want this to be true for you guys, and your generation, but even now today, with everything that we've learned and all the advances that we've made, I mean, I still hear people in circles talk about female scientists that are successful, that are driven, that are not afraid to ask for what they want, as just total pains. No one likes them. Stay away from them, and it's really disheartening to see that still goes on today. And I think that we really have to push back against that it's not okay to say that it's fine for the male to speak his mind and be aggressive, and that's fine, because that's, coming from him. And then if the female scientist does that, man, she can get knocked out. And unfortunately, all these connections and all these allies that we make, these are the people that are reviewing your papers and reviewing your grants. And, it doesn't have a lot of
place in a professional setting. And I think in that sense is, some people still have different feelings about most of those scenarios. But I think, again, being able to bring mediation to those topics means being proactive and being always willing to actually look further than sex or any other possible thing that we were looking for. So I think it makes sense in every sense of the way. It is something important. And also, again, to understanding we try to do that as much in here, and also in the societies that we're a part of, which is, I don't think the word is inclusiveness, but being real, or being normal or nice, and all of those things that people sometimes forget about, being cordial and being respectful for people. I think that also helps with understanding that other people go through different things. We just have to be sure to talk about those things. But you're right, in those settings, there are still some weird scenarios where we try to eradicate those together. And that's why bringing up the experiences from people like you, other people that we've interviewed, helps in understanding some of those scenarios and avoid them completely. So we appreciate it.
I think that we have to hold our leaders and our institutions. We need to hold them responsible. You can't talk about inclusion and diversity and equity and fairness and then not demonstrate that. I think we're getting pretty fed up with that. It's not enough just to have that at the bottom of your email.
I think that's what it is. That's what it is.
If you really, we want to see you actually doing that. So, we want everybody to be treated fairly. However, and so I think that kind of has to end.
Yes, agree. Totally agree. So let me see. We have a couple more, and then I guess it's related to it, but it sort of makes sense about when you're giving people advice about their research interests or academic research. We see a lot of people going into the industry. But if you weren't a researcher in STEM, what would you be?
Oh, and I could be anything I wanted?
Yeah.
Wow.
Movie credit?
I mean, I always wanted to go to medical school. This was always in the back of my mind. This was something that I wanted to do. Saying that, I did not take any pre-med classes. I couldn't take a standardized test to save my life. And so I knew very early on that was never going to work out. This career happened a little bit by default. So if I could do anything, it's a really hard question, I think.
Because they give you you have so many options and people
there's too many options.
Yeah.
I mean, if you would have said you could do anything in science or with your degree, right?
Was there something where you were thinking about that, maybe, because sometimes what we ask people is was there something that defined your trajectory, right? You decided to go into industry because of, I don't know, something, right? But was there something that you were doing before or something that you were really passionate about and you thought about it, but then other things came into mind? Was there something like that?
Yeah, I mean, like I said, when I think back, the only thing I ever really thought I wanted to do was medical school. But another one that I felt pretty passionate about, and I even did a little bit to try to move into that pathway, was law school. I think that, I love to debate. I love to discuss things. I think that I might have been a pretty good lawyer. But again, a lot of things like standardized tests get in the way. And if you can't do stuff like that, I just can't. I'm really bad on
and they
those.
just happen to be the entrance exams to
That's all you have to do it, right? It's not like maybe you can pass this. I mean, so yeah, when we had to do the standardized test in school when I was in high school, and the Army came in with their test, and then 2 weeks later, all of my friends were getting called from the Army, recruiters, and I said, nobody's calling me. I don't understand why. And then when I got my test back, I realized that I had, and this was literally 50 questions of 2+, 5+, but I had marked wrong. And so all of my numbers were off. And so I looked like a total moron. Of course the Army didn't want me. And I'm like, okay, well, I will be lucky if I can get out of school passing this stupid STAR test or whatever. So yeah,
those are going away, by the way. The new.
Yeah, thank God, because I think they're the worst. I think
they are. They're not. I think it's sensitivity is 40%. I think for an overall, so no specificity or almost no. So yeah, I think it makes sense. But yeah, I think also globalization also helped. If you want to be in health, but you don't want to be a physician or you want to be something close to it, you can be very close to people they didn't have in the past. In the past, it was medicine or nothing, right? Now, you can be a PharmD student, you can be a whatever, something. And then
there are so many more options.
You'll become an asset to a group that in the past, it was not an option. So that helps a lot with people.
Did you guys, you're so young, but did you guys ever play the game of life?
Thank you, but no, I'm not that young.
Yeah, you are. Well, way back in the day, I don't know how it is now, but way back in the day, you had to land on the career, right? And then you started the game. And it was literally janitor, doctor, lawyer. And I would roll until I would get the better career every single time, as if you can't have a life as a janitor or whatever. I mean, this was, from
thank God, because now I heard that if you ask people nowadays, YouTuber, what was it that I heard the other day that they asked kids? YouTuber, I don't know. There were 3 questions: no police, no doctors, no nothing. The most asked questions, and the answers were YouTuber or something else like that, or millionaire. I think it was millionaire or something.
Yeah. Okay. Well, you didn't
just a millionaire.
I didn't know that was an option earlier when you asked me. So yes, I would like to win the lottery and just open a dog rescue or something, and then that's it.
I'll add that.
Yeah, add that one in there.
Okay, so I kind of have a fun one. If mast cells and cholangiocytes got in a fight, who would win?
Oh my God. Of course, the mast cells would win. They would kick everyone's behind in whatever tissue they're in. They're few but mighty. You only need a couple of them. And yes, they would destroy all of the cholangiocytes. And they're also female, by the way, with little capes.
Okay. Okay. If you had an at-bat song, what would that be?
I'm sorry, a what?
You know when a baseball player goes to bat and they play a song? What would yours be?
At-bat song. I like that. That's fun. Oh, I love all this dates me. Now I need to feel like I need to think of something that's now. I would have probably Take On Me by Aha.
Oh, great one. Great one.
Like, favorite song.
One of my favorite ones.
All right. Well, thank you so much, Dr. Francis, for speaking with us today.
Thank you, guys. Thank you both.
And now for our article highlights. Our first article is from the American Journal of Pathology. For all of you liver lovers out there, this one is for you. Non-alcoholic fatty liver disease is a continuously growing health problem worldwide. A lot of research effort is going into understanding the initiation and progression of this disease, including identifying and analyzing drug efficacy in preclinical models. In this study, the authors developed a deep neural network-based model to quantify different types of steatosis found in the liver based on pathology whole slide images. They achieved this using the cloud-based platform iPhoria Create, with training data that included over 100 whole slide images from high-fat diet-fed wild-type mice and from 2 genetically modified mouse models that display liver fat deposition, or as we scientists call it, steatosis. A major hurdle in automatically quantifying liver steatosis is to accurately detect the micro and macro vesicles found in hepatocytes or around hepatocytes. In the commonly used hematoxylin and eosin staining, shown in the pink panels at the very top of this image, there exist several structures which contain clear glass, but are not necessarily fat vesicles. And this includes the lumina or opening of vessels, including your veins and arteries, and the bile ducts. The authors were able to train the algorithm to detect hepatocytes and exclude the clear structures of blood vessels and bile ducts. They also trained it to recognize and ignore any sort of artifacts that are generated during the tissue processing and image acquisition process, while still being able to measure the steatosis in liver samples. Their results were supported by findings from expert pathologists and will help create a quick and reliable quantification of steatosis in large preclinical study cohorts. We invite you to check this out at the American Journal of Pathology online. Sticking with our theme of liver research this episode, our second article is from the American Journal of Physiology. Sclerosing cholangitis is a cholestatic liver disease that is idiopathic in nature, meaning that its onset and progression is not clearly understood and can result from various different types of insults or injuries to your liver. In the current study from the American Journal of Physiology, the authors found that preventing the expression of a bile acid transporter called ASPT reduces bile duct mass cell activation, and can alter the bile acid species content within the liver of a mouse model of primary sclerosing cholangitis called the MDR2 knockout mouse. The authors also generated multicellular organoids to understand cellular crosstalk in the liver. These organoids contain mast cells, hepatic stellate cells, and cholangiocytes. Further, the authors confirmed that mast cell infiltration increases in patients with cholestatic liver disease, as well as the bile duct expression of ASPT, the bile acid transporter, indicating that there might be a relationship between bile duct bile acid transport and mast cell infiltration of the liver during disease development. We invite you to check out this article online at the American Journal of Physiology. We hope that you've enjoyed this month's episode, where we got to celebrate and rejoice in Dr. Daisy Shu's wedding and conference honeymoon, got to follow Dr. Roberto Mota's move from Pennsylvania to New Mexico, heard 7.3 questions with Dr. Menglu Yang, and got to know more about Dr. Heather Francis and her research at the Indiana University School of Medicine. Stay tuned for future episodes where we will cover topics like sustainable research practices and transitions in academia. Until next time.